Welcome to this little legacy, this little OG legacy AIBO development intro. This is a little primer I've been working on for the past few months. This will go over the fundamentals on developing for legacy AIBO platforms. The purpose of this is to provide a good starting point for developing on these, to ensure we do not lose this through time. Now, by legacy, I mean by AIBOs that are made around the 2000s that apply. That's the 210, the 220, the 310, the 7, etc. The 1000s are the development firms. The 1000s are different. The ambassadors have done a great job covering those. Obviously, with the 1000s being more modern hardware, more mainstream development through scratch and such. But yeah, this presentation is going to be going over the OG AIBOs only. The ambassadors have done a great job with the rest of the material. The presentation will focus more on developing on the ERS 7. Some of the 210s, the 310s, 220s, they will share the same functions, but all of the samples here provided will be using the 7. It's expected that you have basic programming knowledge. It's good to have it, but you don't necessarily need to have it. It's not the end of the world. Google's always your friend if you need programming advice, and also any advanced programming topics, you can look those up on your own as well. After all, this is just a little primer. Also, do keep in mind, Sony no longer supports any of this ever since the discontinuation of the 7. Around 07, 08, they no longer provide the downloads. It's been a hodgepodge getting all the everything kind of strung up together. So some documentation may be lost in translation, may be archived by others in the community, and you might also need an older computer for some of these. So so heads up on there. All the preface aside, let's talk about the house rules of AIBO development. So we consider the house rules. Always prepare programs in consideration of the safety of the user. This would be, if you want to play by Asimov's playbook, this would be the first law of robotics. Make sure the robot does not injure a human or lead to a human to be injured by inaction. Don't compromise the bonds between robots and humans. That would be the second law of robotics, making sure the robot obeys all human commands unless it contradicts with the first. And also, make sure you don't stress the robot in any way when developing. Don't stress their motors, don't stress their hardware. That would be the third one. The robot must protect its own existence, except if it contradicts 1 and 2. And lastly, make sure the rights of others are respected as such. That's obvious, it's common sense. Okay, so before we go sculpt the marble here, we have to analyze the marble. So let's talk about the anatomy of an AIBO for a second. You have the servos for moving. The robot has the servos for moving around. The camera and infrared sensors for it to see around its environment. Binaural microphones. That means microphones on both sides for listening to commands. Buttons and capacitive sensors all over its body for input. LEDs like the face of an ERS 7 for expressing and output. The processor inside of the AIBO for, well, processing things, and also the storage in the form of a memory stick. I apologize. There's no better way to show where the storage goes. That's up to your imagination. All of the AIBO models for their time used what was the fastest stuff around. We have a ton of all of our modern hardware, like the 1000s, they make that easy. But you have to consider, back in the 2000s, you didn't have that many other options. So when developing the hardware, Sony did what they could, like integrating 64-bit processors. They were already using them in PlayStations and some high-end computers. They already had an operating system already in development for that. It's called Aperios. Aperios is specifically designed for rapid processing. They just hacked it up and put them in the robots and called it a day. And to top it off, they already have a storage format, the memory stick. because they thought, why not put the thing we used for photos in the robots? Said someone at Sony when designing this. And this is essentially the state diagram of how an AIBO starts and stops. So I'm gonna go bring Mira here in the frame, and I'm gonna power on. It locks the battery, and then the OS starts. By that point, it does checks. It'll check the battery, the fan, the hardware. It'll check the stick to make sure the program is going. There's two checks before then going into the software. And now we're in the software and it's initializing. So it would be where AIBO initialize is where this is going. And along with, if there is no memory stick inserted, it'll fall back to whatever fail-safe is in firmware. Right now there is a stick, so now the software is running, it's in operation, and it'll do whatever the software is tasked to do. Until I go and initiate the power off. I'm sorry about that. By that point, it'll go stop whatever it's doing, any stop task it has to do. The operating system will stop, and by that point, it should unlock the battery and the robot goes into suspend. Remember, old legacy AIBOs do not actually power off. The only way to do that is to take out the battery. They go always into a suspend mode. Because they obviously keep time, and there's functions in mind, for instance, that ensure that okay, I want to power up at a given time, so it keeps track of that always. That's why it's in the suspend and not really a power off. So now we're going to go into the development tool, into what makes AIBO development possible. To start everything off, I have to mention what the heck is OpenR. If you look in your instruction manual of your AIBO, or in the memory, or in a programmable memory stick, you're going to see OpenR on it. What the heck is that? It all came from the fact that when Sony was developing AIBO, all the software that was meant for AIBO was meant to be developed by Sony. But there was a whole thing that happened that was like, hey, why do we need to be locked down to Sony software? Why can't we just make our own? So Sony then obliged and permitted the development of third-party software through this OpenR program. So OpenR fundamentally is a standard library. In other words, this is a standardized development suite that you're given to make AIBO software for either hobby use or for research. And you'll notice there's different revisions of OpenR depending on what robot you have. For example, the first generation of AIBO would be 1.0. Then you have the 2.10s, which would be 1.1. And afterwards, they never got past 1.1, everything's iterative. 1.1.1 would be the third gen AIBO, the 3.1, 3.11. 1.1.2 would be the 220. The 1.1.3 would be the super core, and I guess they skipped 4 and they went straight to 5 for the 7. So these are all different. These are all different standard class for each AIBO that introduces new functions. For instance, like the extra LEDs for the 220, or the more advanced, or for more advanced recognition for the 7. Of course, Sony no longer offers this stuff, so there is a project called AIBO Plus OpenR. Now, AIBO Plus itself is made by an AIBO researcher. It's essentially a way for allowing for alternative expressions for 7, and also allows you to connect your 7 with your phone. But what's important here is that it contains a source derivative. It contains a derivative of that OpenR that's supposed to allow you to develop this in more modern hardware. OpenR under Sony was a free as in beer, and this project essentially makes it free as in freedom, meaning that all the source code is publicly available and you're less restrictions in using it. Now this is for advanced development. I just showed you the advanced way to do it. If you're comfortable with C++, you can go ahead and just do this on your own, but isn't there an easier way to develop on this stuff? I just showed you the hard way. Where's the easy way? Yes, there is an easy way to program it. It's called R code. R code is to AIBO what BASIC is to programming. Fundamentally, it provides a simple layer to get an open R platform like an AIBO to do whatever. It's way more straightforward to learn than having to go through a C++ master class for that. And to make it even simpler, there's also YART, AIBO Pets YART, which offers a drag and drop way to program in OpenR, and that also allows for an even easier way to do it. YART itself is a little old, so you might need an older computer for it. But once you get it in there, you're given an R code base, and from there you can drag and drop all the commands you need for all the stop functions. There's also another program called Skitter by DocsBody, and this allows for visual editing of scripts, which can then be integrated into YART for R code development. Moving on, there's two ways to run R code. You can do it the old-fashioned way, which is to run the script locally. This involves regular swapping of the memory stick and also visually seeing what the robot is going to do. It can get time-consuming, and in the case of YART, this might be your only option, but don't let that discourage you from using YART at all. If you will be typing in R code instead of using YART, then it's better to just do it remotely. It provides you like real-time results on what you're typing. So it's either or. It's just a matter of what pill you have to take. In this case, we're just going to take the red one here. So with the R code interpreter base, you can then connect to A7 wirelessly to execute commands on the fly. This is done through a wireless terminal connection called Telnet. You can then use AIBNet, which is also from DocsBody, which doubles as a Telnet terminal and also a development environment for debugging R code. Wait, I said you can do this wirelessly? Actually, you can. If you can bear the fact that it's Wi-Fi 1, and you can either encrypt it with WEP or an open network. They did not do forward thinking with wireless security back in the day. The 7, they did make it with it was made during a time of slightly better Wi-Fi standards, but I'm guessing they stuck around with whatever they used for the wireless card for the 210, and they just put it on the 7 and call it a day. So yeah, you're gonna have to bear with whatever standards there is. It's better to just use an open hotspot that's not connected to the internet at all, like I have set up here for this presentation. But once you get that aside, it's just a matter of just storing the settings using the Wi-Fi manager that comes with the software disk of the robot. So in this case, you would set the drive path for your memory stick, and then configure the SSID, which would be the name of the Wi-Fi, and then either password or no password. But honestly, in this day and age, do you even want WEP? No. All right, so we're gonna bring over Mirage for demonstrating all of the R code today. So give a round of applause for Mirage. So we're gonna make sure we get this set up. I'm gonna go boot up Mirage. I'm gonna go fire up Windows and get AIBNet running. So this is AIBNet. You're gonna have this big command. This terminal space. This is where all of the terminal output will go, and then you input commands right here on the bottom. We're gonna let Mirage boot first.
Yeah, it's weird. It goes down like yeah, it's not like custom data. It has like 3 series and 2 series like noises that you can put on. Somebody wants to go to Hawaii.
And with any luck, we should be able to connect to Mirage.
Don't film me now, girlfriend.
12 seconds later.
live demo gremlins.
Oh, okay. I see the problem. I'm supposed to connect to AIBOnet in here, and then it'll work. With any luck, unless I have to. Don't worry. I'm gonna keep going with the slides while I get Windows booted up again. So. Okay, let's just forget that happened. Let's move on with, so let's go ahead and move on with the first slides of our code. So let's talk about the rules of our code. Commands in our code are laid out in words and variables separated by colons. So you have one word there for your command, and then a colon, a subcommand, and then another colon, and then let's say a value. Words may only contain alphanumeric characters and underscores. They cannot have any other character. Spaces and tabs are ignored. They're reserved for indenting, which makes the code more legible. Lines that begin with just a colon are labels. These labels you can jump into at any point in the script. So, for example, we can have a label that does a function kickball. So I can go to kickball and it'll go over there. Anything that follows double slashes are treated as comments. These can be used to denote whatever the program will do, which makes it easy, which helps out in debugging along with reading the rest of the script. Values can be stored and represented as hexadecimal, octal, and binary. So, which allows for whatever preference you want to, whichever preference you do, because there's some developers that might want to use hex representation to store numbers instead of just regular decimal, binary as well. Let's go more into variables. As we've seen here, we can set variables. So let's go more into detail. Custom variables can be assigned by the user using the set command. So set colon, and then let's use the letter x, colon 100. So now we have a variable x that stores the value 100. So if I reference x, okay, that has 100 on it. Values can be recalled as either a decimal or hex. I'm sorry, fans of octal. And we can use the print function as an example of how to recall variables. More on that in a little bit. But print can be used in general for just debugging or having like some sort of feedback on there. So print colon hello world. We can have a print function set. Okay, I'm going to do this now, or I'm going to do that now, which helps out in debugging. But using variables, but we can use the print command for variables. Now we don't need to create custom variables here because the AIBO system itself already gives us variables. They're called system variables. These are static or dynamic values about the current status of the robot. For example, we have the battery rest command, the variable. This variable contains the current battery percentage that's left on the robot. So I could have a print function that says print colon I have this much percent of charge left. Using %d or %h to represent. In this case, we're just going to present it as decimals. So in the print function, it's going to be %d, and then we have a colon, and then we put the name of the variable on the side. So now I have 80% of charge left. AIBO type provides the model number of the robot running the script. So again, with the print, IMNERS %d colon AIBO type. So that means if you're running a 7, it would be IMNERS 7 or IMNERS 220. This could be useful if you're creating an R code that covers for multiple generations of robot, and you want to make sure you run these functions for this model, for these sorts of models or others. And you also have date variables, which you can use for running certain actions at a given time of day or a given day or month or year. So we can do like a print, and we can do it as now %d colon hour, and we can have hour for hour colon min for minute. We can stack these. We can stack two variables for output. So now this will say, attention, it is now 3:05 p.m. Or in 24 hour, that would be 15:05. There's a whole list of other variables in the R code reference guide here. In the AIBO stuff wiki, which has the official Sony R code reference guide for each model of robot archive in there. With any luck, we should be able to get Miro working again. If not, I'm going to pull out the other computer. Mirage, I'm sorry.
Better behave, ma'am.
There we go.
Nice.
Okay, so now that I'm connected to Mirage, she is now suspended in animation, which now allows me to control Mirage. I can go ahead and go through the variables as we've seen before. We go here on my slide, on my couple of slides here, to demonstrate the R code variables we have gone through. So we can go ahead and do set, in this case we're going to go with X. For the variable, we can store 150. So now we set 150, a value of 150 to X, and then we can use the print command, %d, and then X, and with any luck, we should get 150 in there. And then we can use battery rest, so print, I have,
Jack, so in our code, all use variables are implicitly typed. You can shove in whatever you want. Decimal, text, whatever.
Yep.
Okay.
And then if we go here, I have %d of charge left, and then battery rest. You can see Mirage has 56% of charge left. And then over here, and then also the whole. The time might be wrong, but just for giggles, it's currently 10:35. Well, she thinks it's 10:35 in the morning. All right, so now we've gone over variables. Let's go make the robot move already. We use the play action command for moving the robot around and doing other actions. So walk, it's obvious the dog will move at a steady pace, provided a direction of travel in degrees and distance in millimeters. So play :action :walk. That will make the AIBO walk. :0, so it'll just move straight forward. And then :100, and it'll move 100 millimeters. There's turn, which will make the dog turn around in place without moving forward or backwards, only needing the direction. So play action turn :90 will turn the dog around 90 degrees. Sit will make the dog sit down where it stands. Play action sit. There's no other thing. It'll just sit down. And moving head around will make the dog move. Will make the AIBO look at a certain direction, given a 2D coordinate in degrees. So play action move head. 30 will make it look 30 degrees to the right, 30 degrees to the top. Hopefully I got that right. And then there's a bunch of other actions also in the R code reference guide. So if we go and connect again to AIBOnet to demo that. ID. Hopefully we can still get a response. Yes, we do. All right, so we're gonna do play action sit. So now Mirage will sit. The Arco panel will always confirm your command by outputting the command again. So, and Mirage is now sitting. But let's make her stand. So there's another command. Let's make her stand up. She is now standing up.
Yay.
Round of applause for
Sure.
yourself.
All right. So next up, let's make her move already. So play, action, walk. We're just gonna move straight forward, and we're gonna move, I think 150 millimeters should be fine, and go. Okay, let's go 500.
Small unit of measurement. It's not like a 1 millimeter, do they even use it?
They move this much. All right, and then we're gonna do play, action, turn, minus, let's say 60 degrees. Okay, so that's moving to. Last but not least, let's do move head. So move head 30, 30. Hopefully this works. Yep. Now she'll look around the room. Yep. So let's. And then one more play, action, lie, so she can lie down and rest for a little bit as we move on to the rest of the presentation.
Can they do more like complex moves? I know you can like put them together, but I know for the 1000 API, there's like a play trick option that lets them play like hand skits. And there's also like bar.
We'll get to that right now, actually.
Oh, perfect.
All right, so round of applause for Mirage. For doing all the actions right. That's great. So we can indeed call skits with our code. The skits in legacy AIBOs are assigned a middleware catalog ID, known as an MWC ID, which allows you to run any skit. In this case, for the 7 domain, any sort of suite in the R code base, which has an assortment of mine skits already. It allows you to run these skits at will. Dog's Body Net has some more information about how middleware catalog works. And in this case, you can utilize the existing functions that come with Mind, or you can create new skits with Skitter and integrate that with your R code program. All of the Mind actions are referenced in this website. It is in Japanese, but you can use Google Translate for it. And this will give you a whole complete list of all middleware of all middleware IDs for each of the Mind skits. And to run those skits, we use play MWC ID to run these skits. Now keep in mind, some of them can already be referenced by name, like Bark or something, like Bark or whatnot. But you can find those in the R code on the R code reference guide. You can go to the new commands. Okay, so play MWC ID, and let's go with this one, 3192. She'll go ahead into her neutral stance for that skit. Three 192 corresponds to a bar. 2738, she'll say hello. And 3000 is, I'll let that speak for itself. So yeah, that's kind of the possibilities of integrating skitters into your Arco program. And 1,000 notices another 1,000's birthday and also happy birthday.
Can you include English talking in, like, can you play back English talking scenes? Like any of their voice prompts?
What I'm aware of, not that I'm aware of. I'm very certain the guide here corresponds to all basic sound skits rather than
not the actual
English
skits.
skits.
Like, you know, like make one walk up to somebody and say hello in English.
Whatever.
Yeah.
Whatever.
Yeah, so when I picked up the ball the other day, he's like, I don't like where this is going.
Oh no, I'm the worst I will ever.
Oh no!
I can't make my girl say that again.
Ever. That's right. I'm sorry. I did it.
Mama.
I just want to go through, I just need to create a program that just goes through all of them.
That would be
So it's all
We
there.
need that for the 7 because
This one's going to be a bit of an addendum, but you can have the dog run their own website. This allows you to host a website in your AIBOware, which can be used as an electronic manual, like say, okay, you can say these commands and it'll do this, and other information like the robots, like you can have like an R code script that might include like, here's some commands, here's more information about the dog. These are stored in the directory OpenR app PC, and you'll see pretty much all the web files in that Arco distributable. If you go into the files for Mine software, you'll notice all those pages as well. And Mine can actually dynamically use form documents. I have not gone in time for this presentation to go over how these work, but these can be explored too at anyone's free time to explore the possibilities of hosting little web pages on your Arco program. It's a little bit of an addendum. It's not necessary, but it's good. But it's good to know that there's like those little freebies you can have for that. Okay. Now that's everything done. Let's go ahead and run a more involved Arco program. We're going to look for this one. And now we can see on the bottom, we have this little proper demo R code. This is a little voice recognition demo. It initializes for the commands, and in here I program and in the script there is programming for waiting for a command to be heard. There's going to be 5 commands that I will say, and it'll correspond to these calls. So it's a little more involved, so I'll be descriptive. So this start command will prepare. It will call. It'll jump to the function prep move. So prep move will make the dog stand. She's already standing. And then we'll set the AU voice. AU voice is the recognition. So that'll mean. So we set it to 0 to ensure. Oh, okay. I have not heard a command yet. So it'll then go into the loop. So it'll do that command, and I'm very certain infinitely. So it'll go through this over and over. So we're just gonna filter that out for a bit and make this easier to read. So if AU voice equals 1, so that means okay, I've detected that I've heard something. So then we go into this switch statement. So essentially, it's gonna find out what command it has heard. So AU voice ID is the ID corresponding to that certain command. So there's 5 commands we can see here, and they all correspond and go to a particular point in here. And then it'll reset and it'll wait for the next command. So it's a little involved, but I will share the code so you can look at it after the presentation. So let's go ahead and start the program. With any luck, you should be able to hear. I'm gonna keep these notes here for this presentation. So let's go ahead and go through these in order. Showtime. Do a little bow. Say hello. Clown around. Like to fart again, are you serious? Don't do that. Don't do that. Okay, yeah, that might have sounded a little too harsh. Sorry. So, yeah, those are all the 5 commands for it, but it kind of demonstrates you some of the capabilities of what our code can do. Okay.
Clown around. Darn.
Yeah.
You're not my mom.
All right, so we're gonna stop the script, and then Mirage can go lie down again. Play action lie. Oh, where's the phone? And now Mirage can rest a little while, and that's the R code demo. Okay, are there any other, okay, so now that we wrapped up everything, any questions, comments?
Well, nice job, first of all. Thank you.
Excellent job.
Any questions? Going once, going twice.
That's 1,000 has a question.
I already asked mine.
I'll offer up, if I'm not doing any R code stuff, but just for cheap AIBO net, Amazon's got a TP-Link 3000 nano router, it's like $30. That,
As long as you configure the Wi-Fi to 802.11b, it should be fine.
you can do that, you can drop security, but then the other thing is if you do that, and you do connect it to your home router and you bridge it, put Mac filtering on.
Yeah.
So if anybody needs help with that,
Yep, that's
there's
one.
a number of us that can help.
Yeah, that's, I never thought of that.
But that's, at least it's, you can still Mac clone, but the likelihood of my neighbor Mac cloning something to get on my network is
Right.
quite small.
Yeah.
Well done, sir.
Yeah, thanks for being.
We haven't seen one like
Seven's a clown around more now.
You like that,
It's fun.
I didn't know about that command.
Neither did I.
Which one,
I know
Bentley's?
I know the like keys, I know these two.